Section 7.6 is about solving equations with radicals. So let's take a look at what that means. So to solve a radical expression, or one containing square roots, the first thing you're going to have to do to solve this is to isolate our radical. Then what you need to do is square both sides of our equation in order to eliminate the square root. Now you could be working with a cube root and then you need to cube both sides of the equation, but right now we have a square root. Next you're going to want to solve the resulting equation and then check all proposed solutions in the original equations. Now, normally I'm like, it's cool, we don't need to check the solutions, especially when we're working with linear equations, right? But for these, you have to check solutions, and I'm going to show you why throughout the course of this PowerPoint. So, the first thing we need to do is isolate the radical. Well, that's already been done for us. The radical is by itself on the left-hand side of my equation. I can then go ahead and square both sides. Remember that squares cancel out square roots. So I have 3x plus 4 equals 8 squared, which is 64. I can then go ahead and subtract 4 from both sides. So I get 3x equals 60. I divide both sides by 3, and x equals 20. Okay, now I said you have to check your solution. So I'm going to plug 20 back in. So I've got the square root of 3 times 20 plus 4 equals 8. That gives me the square root of 64 is 8, which is true. Okay, so x equals 20 is a solution. So that step 4 wasn't so exciting. Let's take a look at the next example. So the first thing I need to do is isolate the radical. I have the square root of 5x minus 1 plus 3. So I'm going to subtract 3 from both sides. I get the square root of 5x minus 1 equals negative 3. I go ahead and square both sides. That's my step 2. That gives me 5x minus 1 equals a positive 9. I go ahead and add 1 to both sides. That gives me 5x equals 10. So I have that x equals 2. Now I'm going to check my solution. I'm going to check my solution over here. If I have the square root of 5 times 2 minus 1 plus 3 equals 0, I get the square root of 10 minus 1 plus 3 is 0. So the square root of 9 plus 3 equals 0. Now remember, when I'm taking the square root, I'm always taking the principal square root unless I say otherwise. So I have 3 plus 3 equals 0. This is false. So because x equals 2 is not a solution, there are no solutions. No solutions. Okay, let's try another example. So step 1 is to isolate the radical, which we've already done on the left-hand side of my equation. Then I have to square both sides. Well, if I square my left-hand side, I'm going to get 4 minus x. But I need to remember that x plus 2 squared, that's like x plus 2 times x plus 2. So I have to FOIL this out. I'm going to get x squared plus 4x plus 4. I'm then going to go ahead and move everything to one side of my equation because this is a quadratic, so I need to set it equal to 0 to solve. So I take away 4 from both sides, I add x to both sides, and I get that 0 equals x squared plus 5x. I can go ahead and pull out the greatest common factor, which is going to be x. So I have 0 equals x times x plus 5. Now I want to set each of these factors equal to 0. So I get that x equals 0 and x equals negative 5. Now is step 4. I have to check all proposed solutions. Okay? So let's see if x equals 0. And I would have the square root of 4 minus 0 equals 0 plus 2. So the square root of 4 equals 2. 2 equals 2. This is true. So this is a solution. Let's go ahead and check x equals negative 5. If x equals negative 5, then I have the square root of 4 minus negative 5 equals negative 5 plus 2. which gives me the square root of 9 equals negative 3. Well, that's false. The square root of 9 is 3. So x equals 5 is not a solution. That means my only solution is x equals 0. And we wouldn't have known that if we hadn't checked our proposed solution. So make sure that in the homework you are doing that so you get the correct answers. Make sure you're doing it on the exam that we have coming up as well. All right, step 1, isolate the radical. We've already done that. Next, I'm going to square both sides. Remembering that squares cancel square roots, so I have x squared minus 4x plus 9 equals x minus 1 squared. Again, I have to FOIL that. So I get x squared minus 2x plus 1. I'm going with that. Next, I want to move everything to one side of the equation, so I subtract x squared. I add 2x, and then I subtract 1. So I get negative 2x plus 8 equals 0. I go ahead and move my 8 over, so I subtract 8 from both sides. That gives me negative 2x equals negative 8, so x equals negative 4. Let's go ahead and check this solution. If I have, here's where I'm checking my solution, negative 4, it's not negative 4, it's positive 4. If I have positive 4 squared minus 4 times 4 plus 9 equal to 4 minus 1, that gives me the square root of 16 minus 16 plus 9 equals 3. The square root of 9 equals 3, 3 equals 3, x equals 4 is my only solution. Now for our last example here, we're going to have to follow these steps multiple times, and here's why. We're going to have to square our equation a couple times. So the first thing I want to do is I want to get one radical on each side of the equation. So I'm going to subtract the square root of 3x plus 4 from both sides. I could have subtracted the square root of 5x plus 6, but that's just what I'm going to do. You'd get the same answer. So if I have the square root of 5x plus 6 equals 2 minus the square root of 3x plus 4, I'm going to go ahead and square both sides. My left-hand side, real easy, becomes 5x plus 6. It's my right-hand side that's a little more complicated because I have to FOIL, right? I have 2 minus the square root of 3x plus 4 times 2 minus the square root of 3x plus 4. That's what this square means. I rewrite it because it helps me see how to FOIL better. So I have 2 times 2, that gives me 4. 2 times a negative square root of 3x plus 4 gives me a negative 2 square root of 3x plus 4. Negative 3x plus 4 times negative 2, that gives me a negative 2 square root of 3x plus 4. And then a negative square root of 3x times a negative square root of 3x gives me a positive 3x plus 4. I'm going to go ahead and combine like terms. I get 5x plus 6 equals 4 and 4, which is 8, plus 3x minus 4 square root of 3x plus 4. So I'm going to go ahead and subtract 8 from both sides and 3x so I can isolate my radical. So what's that give me? That gives me 2x minus 2 equals negative 4 square root of 3x plus 4, which I'm going to go ahead and square both sides again, making things a little chaotic, I know. Negative 4 squared is 16 times 3x plus 4. My left-hand side squared, that gives me, because I have to FOIL, 4x squared plus 4x, minus 8x. Then I have to distribute this 16, so I get 4x squared minus 8x plus 4 equals 48x plus 64. This is very exciting. What I need to do now is I need to go ahead and combine like terms. So I'm going to take away 48x from both sides. I get 4x squared minus 56x. I subtract 64 from both sides. So I get 4x squared minus 56x minus 60 equals 0. I can then plot a factor of 4. That gives me x squared minus 14x minus 15 equals 0. And then I factor this right here, so I have 4. The factors of negative 15 that add up to negative 14 are negative 15 and 1. I set each of my factors equal to 0. And I find that x equals 15 or x equals negative 1. I'm not done. I still have to check my proposed solution. So I'm going to rewrite up at the top x equals 15 and x equals negative 1 because those were the two proposed solutions I found. If you are not finished copying these notes, this would be a great time to pause. Make sure you didn't miss a step. But I'm going to go ahead and make us a little more room so that I can complete step 4 properly. So next I'm checking my solutions. So I have x equals 15 and x equals negative 1. So here's where x equals 15. So I have the square root of 5 times 15 plus 6 plus the square root of 3 times 15 plus 4 equals 2. Well, this gives me the square root of 81 plus the square root of 49 equals 2. So 9 plus 7 equals 2. Well, that's not true. This is false, right? So x equals 15 is not a solution. I still have to check x equals negative 1. They could both not be solutions. So the square root of 5 times negative 1 plus 6 plus the square root of 3 times negative 1 plus 4 equals 2. That gives me the square root of 1 plus the square root of 1 equals 2. So 2 equals 2. That is true. So x equals 1 is a solution, and it is the solution.